Ready. Very good afternoon to all the students who have logged in today. Today we have in fact yesterday we received number of responses, queries. So welcome to the virtual coaching class for today, the 9th of July, and we are taking up matrices, and we'll take up linear inequalities. Now yesterday, of course, we completed with determinants, and we also talked about different type of matrices. We looked at scalar matrix, we looked at, we had row matrix, column matrix. So, number of queries have come. I thank each and every one of you for responding and for sending in your doubts and queries. I have prepared a detailed sheet of that. So let me take the queries one by one. Now Divya from Bangalore, the first person is Divya from Bangalore. Now she has asked a question: where do we find the solution for exercises to the study material? Divya, thanks for asking. You will be finding the answers to the study material questions at the end of each exercise. You will find the answers are given, the solutions are given. Second, we have Khushi Agarwal. Khushi from Raigad has asked a question whether a test will be taken by ICAI in these virtual classes. Now, as of now, there is no news of any test, but I'm sure if there is any update, you will come to know of it through online mode. Okay. Next is B. Gayatri from Chennai. Now, she has asked an important question: will there be any mock test before the November exams? Normally, every year before the exams, 1 month before the exams, mock tests are held, and the question paper and the solutions are uploaded in ICAI website. So definitely this time also, I'm sure there will be mock tests. So please keep watching the website icai.org. And another important request to you, please go through the CA student newsletter. I'm writing it, the CA student journal. So this is the ICAI CA student journal. You will be getting all the updates, not just on mathematics, not just on accounts or economics, but also on exams, also on mock test, and a wide variety of updates on the current business scenario. And you have a paper, Business and Commercial Knowledge. So please go through this. Every month it is published, and you can download it from the institute's website. Okay. Thanks for asking this question, Gayatri. We now go to the next query. We have received 179 queries, 179 doubts. So thanks a lot to each one of you for sending in your queries. I have shortlisted around 60 queries, and I'll be handling one by one. So I'm also mentioning your name and the place. So before we start with the matrix and determinants and Kramer's rule, I will go through the queries and try to give my responses. So Astha has asked the question. Astha is from Shivpuri. I'm sure Astha, Gayatri, Khushi and Divya are part of the session now. Astha has asked the question: sir, is study material enough for the exams? My answer is yes. Study materials are the best way of learning any subject, mathematics also. And you also have your model test paper and the additional question bank which is there. Please go through the study materials. We are trying to solve most of the questions from the study material, from the exercises, from the mock test paper, and also from the question bank. So these should be more than sufficient for your preparation if you do it diligently. Right. Next is Sonal Munka. Sonal Munka from Thane. She has asked the question. She has said that the additional question bank sums are very tough. Please do those questions. Okay, Sonal, you also said that your doubts are not answered, but I'm sure now you are happy. I have seen your doubt and I have noted it. I will take problems. Already I have taken problems from additional question bank. I will take more problems for every chapter as we go forward. So I hope, Sonal, you are happy now, and I have mentioned your name and place. You are from Thane. Okay, next is K. Durga Jyoti from Chennai. Now, she has asked the question that logical reasoning and statistics is not given in your in the sheet, in the Excel sheet, which contains the schedule of classes. So I think the timetable may be updated. Durga Jyoti from Chennai has stated whether logical reasoning and statistics will be included. I think it is better if you talk to the Board of Studies directly. I am sure the timetable will be updated and statistics and logical reasoning is also going to be included in these virtual coaching sessions. Next is Atul Khatri from Rajasthan. Atul Khatri from Rajasthan, I'm sure Atul is there. Now he has said, I don't have my study material yet. 10 days ago I registered but I'm not getting it. How to study mathematics? My request is please download the study material soft copy from ICAI.org. I mentioned yesterday also, please go to this website and you go to the foundation, CA Foundation, you will see the names of the papers, accounting, you have law, you have mathematics and statistics, BCK, logic, your economics, everything will be there. You can download the study materials, plus you can download the model test paper and the solutions also. So Atul, I hope your problem is solved. Next is Akanksha Avasthi. Akanksha Avasthi from Bangalore. Now she has asked, in order to pass the subject, do we have to get minimum marks in mathematics, statistics and logical reasoning? Yes, you have to get a minimum marks in mathematics, logical reasoning and statistics in order to qualify in the overall paper. Okay, next I move on to Giri from Chennai. Giri from Chennai. The question is, sir, if we did not attend the question, will there be a negative mark? Very important question. Thanks, Giri, for raising this question. I told you that yes, if I give a wrong answer, I lose marks because there is negative marking. But if I do not attempt a question, yes, there is no negative marking for that. Next is Vranda Agarwal from Navalgarh. Now she has said, is the standard of problems in the maths exam more difficult than the ICAI module? Thanks, Vranda, for asking this question. More or less, it has been seen from experience that most of the questions in the exam are, ultimately they are linked with many of the questions in the study material and in the additional question bank of the institute. Plus, I request you to go through the CA student newsletter. Every month you will see that the institute covers an important part of your foundation curriculum in these newsletters. Very recently, in the month of May and June, if you see the CA student newsletter, you will find lot of inputs and number of numericals, solved problems, solutions being given for a very important chapter, time value of money. So please go through this, and I'm sure study material along with this will make you ready for the exams. The questions will be more or less of the same level. Okay. Next we have Harsh Chaudhary from Odisha. His question is, how should we solve problems from our study material if he is unable to understand, and how to proceed? So I see your problem. The solution is solving more problems, and please take the virtual coaching classes as seriously as possible. I am responding to individual queries so that we are in touch, we are connected, and I am also sharing important inputs like requesting you to go through the CA student newsletter, and please go through ICAI.org plus the YouTube channel ICAI CA Tube. You will be able to see all the videos, and this will be more than sufficient for your exams, for getting ready for your exams. Next is Anshika Gupta. She has asked a question, sir, according to ICAI schedule today, you are teaching matrices, but you are teaching equation. So my answer, I have already responded back yesterday. I covered matrices. Also, I covered, equations, because there were so many queries. Even though yesterday's session was on matrices, but so many queries are there from your side. And of course, equations is not an easy chapter, so I had to spend time. Today also we'll spend time on that and move into inequalities. M. Sudarshan from Andhra Pradesh. Sir, what is a rectangular array? I said that, let me explain it quickly. Rectangular array, many of you have the same question, I'm sure. Many of you will have the same question. Rectangular array. Now, many of you have asked in the question you have asked is, what is an array? Now, array, A-R-R-A-Y. Array is nothing but an arrangement. It is an arrangement of numbers. So, 5, 6, 7, 1, 4, 0, minus 1, 9, 6. This is an arrangement of numbers. You can see here, how many rows do we have? First row, second row, third row. So, 3. How many columns do we have? 1, 2, 3. 3 by 3. So, it is a square matrix, right? But a square array you can say. But rectangular array. What will be a rectangular array? Okay, I remove one column. Okay, so now the matrix is 5, 6, 7, 1, 4, 0. So, it becomes a rectangular array. I will discuss more about it. Next question has come from Riya Kumari from Jharkhand. Riya Kumari. Sir, please explain once again how to solve problems using cubic equation. Cubic. I discussed about the trial and error method of solving cubic equations. I will take more example if time permits. I have kept a note of your question, Riya. Thank you. Next is Sahil from Haryana. Sahil from Haryana. Question is, sir, can we do it with the help of matrices method where we can get the value of x, y, z? Yes. In case you get a question, solve for x, y, z. You can use matrix method. Of course, matrix method means Kramer's rule, which we will do today. Next is Pujita Chaudhary from Andhra. Pujita Chaudhary. Question is, sir, can there be a negative number in the matrix? Yes, Pujita, there can be a negative number in the matrix. You can understand, I have taken, let me take another matrix here. Say 5, 4, 3, minus 1, minus 2, 7, 0, 1, minus 9. Yes, there may be negative numbers in the matrix, right? Because matrix is an arrangement of numbers. It is an array of numbers, and you know that numbers can be positive as well as negative. Right? So I think, Pujita, you have understood your question. You have got your answer. Next is from Gangtok, from the beautiful city of Gangtok, the hill city of Gangtok, Savi Mangla. Question is from her, the question is, sir, how to write the order? Is it row and column? Yes, it is row and column. So here, any matrix, if you write, we always use row multiplied by column. Okay, so here we have 1, 2, 3 rows. So 3 rows. 3 into columns is 3. Okay, now let me remove one column. So now it reads 4, 3, minus 2, 7, 1, minus 9. Now, the order of the matrix, the order, I am writing order. The order of the matrix is what? Number of rows remains 1, 2, 3, 3. But the columns, number of columns is 2, 1 and 2. So it becomes 3 into 2, right? So please remember, thanks Savi Mangla for asking this. It is, the convention is always row multiplied by column. So it is always row multiplied by column. Okay. Next question has come from Shivani Priya. Shivani Priya from Bihar has asked the question, why matrix is shown in a bracket, right? Why do we write matrix like this in a bracket? And she has asked the same question, what is an array, right? What is an array? Array is nothing but a group of numbers, okay? A group of numbers which can be positive or negative. That is called an array or an arrangement, okay? And why is it written with a bracket like this? Right, to show that it is a group of numbers, right? For example, when you sit with your friends, right, and chat, your friends in a cafe. Of course, now in lockdown, you cannot go out with your friends for partying and for birthday parties and all. You can't do. But imagine those days before the lockdown when you used to go out. So you are always in a cafeteria, you always used to sit in a corner with 5 or 6 friends. Right? Used to hang out together. So, like a bracket. That means you are secluded from the others. This shows that it's an array of numbers which is specifically part of this particular matrix. So this bracket is used. Okay. Next, Ritika from Chandigarh. From Bihar, we go to Chandigarh. Ritika has asked, sir, please explain AIJ. Right? So yesterday I discussed about AIJ in detail. AIJ. Okay? And I also stated that when you move linear in a sideways manner, you have A11, A12, A13, A14, and so on. When you go vertically downwards, you have A11, A21, A31, A41. Okay? So as you go in the downward fashion, okay, in the vertical, what happens is, please see that I increases. I increases. Okay? Aij means any term in this matrix. So you have A21. Okay? So I am filling it up. A22, A23, A24, A31, A32, A32, A33, A34. Here you have A41. So A42, A43, A44. So I have taken a 4 by 4 matrix, 4 rows and 4 columns, and you can see Aij is the generic term, is the general term for any of these numbers. Please note, the question is from Ritika, that as you move in the linear direction, I increases, and as you move in the vertical direction, so as you move in the linear direction, J increases, I increases, as you move in the vertical direction. So as you move in this direction, the second digit increases. And as you move this way, vertically, the first digit increases. So you can see for vertical movements, I increases, and for horizontal movements, J will increase. So this is the concept of Aij. Next is Preeti Kumari from Patna. Sir, can we put comma between two numbers in a matrix? Can we put comma between two numbers in a matrix? Okay. Now, normally in a matrix, how do we write? A, B, C, D. Okay. It is a 2 by 2 matrix. 2 rows, 2 columns. It is a 2 by 2 matrix. Normally, we never use commas. No, we never use commas. We have some space, right? When we sit, now you see we talk of social distancing. Minimum you have to maintain 5 feet, minimum 3 feet. Similarly, when we write a particular matrix, we don't write it too close. We will not write like this. No, wrong. So we have some space. A, B, C, D. Okay. So no commas, but some space is required. Thanks Preeti Kumari from Patna to ask this question. Next again from Avalgarh, Vranda Agarwal. What is the difference between diagonal and scalar matrix? Very important question. I'll take it up. Vranda, thanks to you for asking the question. I am also acknowledging your names and the location from where you have asked the question. I went through each and every query after the session is over, filtered it, and found out the most important queries which requires my response, and I am in front of you today discussing about the queries, because this is an important part of the session. Before we move on with matrix, with determinants, with inequalities, this is important. Vranda has asked, what is the difference between diagonal and scalar matrix? Okay. Now, please note what is a diagonal matrix. Diagonal matrix, dear friends, please note along with me, what is a diagonal matrix? Diagonal matrix is a matrix where the diagonal, of course it has to be a square matrix. Square means you know the number of rows and the number of columns are equal. Okay. Now in a matrix, if you have a matrix like this, say 5, 0, 0, 0, 6, 0, 0, 0, 8. Okay. So what do you get here? 5, 0, 0, 0, 6, 0, 0, 0, 8. Thanks to Vranda once again for asking this question. I had discussed it. I am repeating it for the benefit of so many thousands of students who are logged in right now. Now you see, this is a 3 by 3 because there are 3 rows and there are 3 columns. Fine? So it has to be a square matrix. Only then you will get a diagonal. What is the diagonal? Now I said that the principal diagonal, the principal, or sometimes it is called the leading diagonal, the leading diagonal is, I'm drawing it, this. Okay. So you know diagonal means, the principal diagonal or the leading diagonal means that it is going to join, the diagonal will connect the first digit, right? The first digit of the first row, and it will connect with the last digit of the last row. Okay, the extremes. You know in a square, let me draw a square. Okay, diagonal. This is a diagonal. In a rectangle, diagonal. Okay. So this is called a diagonal matrix, which means that a matrix where only the diagonals are composed of numbers, but all the other numbers are zero. Apart from the diagonal, all other numbers are zero. That is called a diagonal matrix, right? So I hope you have understood the concept of diagonal matrix, a square matrix where all the digits are zero excepting the digits which are on the principal diagonal. Please note the numbers on the principal diagonal are 5, 6 and 8. Okay. Apart from that, all other numbers are zero. So this is the concept of diagonal. Now what is scalar, right? So what is scalar matrix? We discussed it yesterday. Once again, since Vranda has asked the question, let's see what is scalar. Okay, so this is a diagonal matrix. Now I write another matrix. Okay, I am writing another matrix. Let me do one thing. I will write this 6 0 0 0 6 0 0 0 6. Okay, I hope you can see this. 6 0 0 0 6 0 0 0 6. Is it a diagonal matrix? Yes. Why? Because only the diagonal, the principal diagonal, once again the principal diagonal is this. Okay? Only these are numbers, which are positive numbers or negative numbers. All the other numbers are zero. So this is a diagonal matrix, yes. But please note that here each of them is 6. All the numbers are 6. So 6 means it's a constant. Okay, the same number like a k, constant. So a scalar matrix is a diagonal matrix where each of the numbers on the diagonal are same. Okay, so instead of 6, if I write minus 1 0 0 0 minus 1 0 0 0 minus 1. Yes, this is also a scalar matrix. So a scalar matrix is a diagonal matrix where the numbers on the principal diagonal are same, are identical, are equal. Okay. So I hope, Vranda, you have got your answer, and many other friends who are logged in definitely are getting benefit. I move to the next one, Parvesh from Tamil Nadu. Sir, whether in the exam they will ask to solve the equation in a particular method, or we may solve using any method. Normally, if the question asks you that yes, solve the pair of equations or solve x, y, z using matrix, they will tell you. Otherwise, you can use any method. It can be simultaneous linear method, it can be elimination, it can be substitution method, it can also be Kramer's rule, it's up to you. Unless the question specifically mentions. Okay. Next is Shivani Priya from Bihar. She has asked, sir, define matrix. So now instead of me, many of you can give the answer. The answer is, what is matrix? Matrix is an array or an arrangement of numbers in a rectangular or in a square fashion, right? And you know, it can be a row matrix, it can be a column matrix, so on. Next is Lakshmi from Palakkad. She has asked, sir, unit matrix and identity matrix, are they same or different? Okay, thanks Lakshmi for asking this. Because after this, I will move into identity matrix. So you see, the moment I write 5, 6 and 8, okay, this is a diagonal matrix. Fine. The moment I write -1, -1, -1 and the rest are 0, this is a scalar matrix. Okay. But if you have a matrix, I am writing it here. If you have a matrix like this, 1, 0, 0, 0, 1, 0, 0, 0, 1. This is a matrix where the numbers on the principal diagonal are 1. All the numbers are same. There are 3 numbers on the diagonal. 1, 1, 1. Friends, this is called unit matrix. So this is known as unit matrix, also known as identity matrix. Identity, I. It is shown by I. It is an identity matrix or a unit matrix. Okay. So we have discussed 3 concepts. Diagonal matrix, where in case of diagonal matrix, all the numbers in the diagonal are maybe dissimilar and the other numbers outside the diagonal, above and below the diagonal, are 0. Diagonal matrix. Now second is scalar matrix, right? If all the numbers on the diagonal, in case of a diagonal matrix, if all the numbers are same, so if it is say -8, -8, -8, all -8, that means it is same. Then it becomes a scalar matrix, and a particular case where you have only 1, 1, 1 on the diagonal. So here the diagonal is comprised of 1, 1, 1. This is an example of unit matrix or identity matrix. So Lakshmi, you can now understand unit matrix and identity matrix are the same. Next is S. Rishikeshwaran from Pondicherry. Is scalar matrix equal to unit matrix? No. So now I think S. Rishikeshwaran from Pondicherry, I hope you have got the answer. Unit matrix means a number, only 1 will be there. But in case of scalar matrix, it can be any type of number. But all the numbers should be same. But you can always say that unit matrix or identity matrix is a specific type of scalar matrix. Okay, but unit matrix is not equal to scalar matrix. It is a type of scalar matrix. Fine? Right. Next is Sahil Raj from Bihar. What are the differences between scalar matrix and unit matrix? I have discussed. I hope it is clear. Rashi Jain from Alwar has said, sir, can lower triangular matrix have digit other than 0? Answer is yes. Rashi Jain again has asked that can we have null matrix having 3 into 3? Is it called a square matrix? Okay, now 3 by 3 matrix is general 3 by 3 matrix is always a square matrix. 3 by 3, 4 by 4, 2 by 2, 5 by 5. The number of rows and the number of columns, if they are equal, it is a square matrix. Khushi Bharadwaj from Delhi has asked, she has said that if you want, please increase the time of the class, but please explain the topics like this. So thank you, Khushi. Shreya from Karnataka has also asked a question on principal diagonal matrix, which I have explained. Now, Vanshika has asked a very interesting question. Vanshika from Punjab. Now, her question is, in case of unit matrix, okay, in case of unit matrix, I'll once again write the unit matrix. Unit matrix is, you know, now you can close your eyes and write, it is 1, 0, 0, 0, 1, 0, 0, 0, 1. Now she has said that in case of a unit matrix, her example, she has given an example. Okay, I'll write it for you and it's a question to all of you. Vanshika has asked this question. If we have, she has given this matrix 1, 2, 3, 2, 1, 3, 2, 3, 1. Okay, so please note that here also this is Vanshika's question. This is also a diagonal and here also we have 1. So is it a unit matrix? No. This is a unit matrix. Why? Because apart from the fact that the diagonal is composed of 1, the condition is that all the other digits outside the diagonal should be 0. Okay? So this condition is not satisfied here. So Vanshika, I hope you get the answer. This is not an unit matrix. Okay. Next we have Mohammed Farhan from Oman. So welcome to the session. So we have our esteemed students from outside India also. So it's an international batch which is going on, and hats off to ICAI. Thanks to the Institute and the gratitude to the Institute for organizing these free sessions and making it possible. So he has asked a question: can a submatrix be formed only by blocking the middle two rows? Okay, so let's go to submatrix. Okay, so you see, by answering the queries, we are doing a revision of the entire chapter, and many of your questions may be asked by your friends, so you are able to get your clarification, right? Your doubts are getting clear. Thanks to each one of you for sending the questions. Okay, so let me draw a matrix here. The matrix is 1, 2, 3, 4, 7, 8, 9, 10, and -1, -2, -3, -4. So please note the number of rows is 4. 4 rows, and the number of columns, number of rows is 3, Number of rows is 3, and the number of columns C equal to 4. So this is a 3 into 4, 3 by 4 matrix. Now, how can you form a submatrix? Okay, how can you form a submatrix? So we can just block this, for example, the middle row, and let us block the third column. So 1, 2, 3, the third column. Okay, so you get a submatrix. You have 1, 2, 4, and you have -1, -2, -4. -1, -2, -4. So this is how we form a submatrix, and you can do it for other types of matrices also. Okay, Kunal from Chennai. Is submatrix always a square matrix? Okay, now necessarily it may not always be a square matrix. Now he has asked a question for a 2 by 4 matrix. In case of a 2 by 4 matrix, Kunal, the submatrix will essentially become a row matrix. Okay. Tanushi Vaish has said how to add if the order of both matrices is different. Okay. We discussed it yesterday. Quick recap. Now, Tanushi has asked this question. Tanushi Vaish. The question is how to add if the order of both matrices are different. So matrix A and B. This is 3 by 3 and B is 2 by 2. Order is different. Can you add them? No, you cannot add them. Okay, so we know that in order to add matrices, 2 matrices to be added, right, it should have the same order. Order means you know number of rows and columns, right? So this is a dissimilar matrix, not of the same order. You cannot add it, right? I move on to Aarti Anand. Aarti Anand's query is from Bhubaneswar. Please explain symmetric and skew symmetric matrix. Okay. Now, symmetric matrix I'll take up after some time. Symmetric and skew symmetric. Right. Sanjal Bankar from Wardha. Please explain equal matrices. Okay. Equal matrices. Okay, fine. What is an equal matrix? Okay. And he has, Nazmeen Khan from Maharashtra has also asked, what is symmetric matrix? I'll take this little while later. So Aarti's question and Sanjal and Nazmeen's question I'll take little while later. Okay. Aditi Shah from Amlai has asked, if in the exam 2 different structures comes, how can we add? My last answer, you cannot add matrices of different combination. 2 by 2 and 3 by 3 cannot add. 3 by 2 and 4 by 2 you cannot add, right? Because it has to be of the same order, number of rows and number of columns have to be identical. Therefore, in the exam, I don't think any such question will come which has dissimilar matrix. If it comes, one of the option will be definitely that this matrix cannot be added. And you tick that option, right? Okay, next is Dhruv Pawari from Rajkot. Sir, can we add 3 by 2 with 3 by 3? The answer is no, as per my discussion now. Harsha Gupta from Jamshedpur. What is a singular matrix? I'll take up later. Divya from Bangalore. Sir, if a question is asked to subtract the matrix, should we, so A is given, B is given. If they ask you to subtract the matrix, so should you subtract B from A or should you subtract A from B? This is the question sent by Divya from Bangalore. Okay. Now, Divya, my answer is always subtract B from A. This is the usual convention. So, if they ask you A minus B, so if C is equal to A minus B, it means you subtract matrix B from matrix A, right? Next is Princey Tibrewal. He has thanked me for conducting the classes in this way. Thanks. Welcome to Princey. Next is Ramya from Bangalore. Should we take 3 in all scalar multiplication? Okay. I will take a small example. Okay. A is equal to 3, 2, 6, 4. Okay. I have taken 3, 2, 6, 4. It is a 2 by 2 matrix. Okay. So I mean writing here, it is a 2 by 2 matrix. 2 by 2. The question from Ramya is, if when we multiply scalar multiplication by a factor k, right? Now k, her question is k always 3? No. K can be any number, Ramya. Right? It can be 1, it can be minus 1, it can be 10, it can be 100, it can be 50, any number. Okay? So k denotes any number, but it may not be, it cannot be only 3 or only 4, it can be any number. But if it is say 4, okay, let us, if it is 4, if k is 4, then in this example, 3, 2, 6, 4, if I multiply this matrix by 4, because k equal to 4, in this example, so what will be the new matrix? The product will be 4 into 3, 12. 4 into 2, 8. 4 into 6, 24. And 4 into 4, 16. So the new matrix is 12, 8, 24, 16. Right? I hope you have got your answer. Okay. Next we have, Ramya, Rohit Agarwal. Okay. Lovely question from Rohit. Rohit is from Jaipur. Rohit has said that he likes the session and thanks. He has thanked me for contributing this lecture. Thanks, Rohit. Rohit has asked a very important question and something which we did yesterday. You may remember yesterday we did a lovely analysis. We took two matrices A and B and we did AB. We multiplied AB and then we multiplied B into A, right, to get BA. And then we saw whether AB is equal to BA, question mark. I told you, if you see the video once again, it is there in YouTube, you will find I told very categorically that under general conditions, AB will never be equal to BA. They are not the same. This is called commutative rule. Commutative. Okay. Commutative rule. Commutative. A into B, B into A. So commutative rule in case of matrix does not hold. So AB is not equal to BA. Please recall the numerical which we did last day. Okay. So this is not possible. But Rohit, a very intelligent person maybe, he has asked the question that under which condition, a very intelligent question has come. Under which condition AB is equal to BA? Okay. There are 3 conditions. For your knowledge, 3 conditions when AB will be equal to BA. Okay. So I am writing here in general, matrix AB will not be equal to BA. No, it will not be equal to BA. But AB will be equal to BA when, first condition, when A is equal to identity matrix. If A is equal to identity matrix or unit matrix, that means it is of the form 1001 or it is of the form 100010001. Identity matrix. Then AB will be equal to BA. First condition. Thanks Rohit for asking this question. Second condition is if A is equal to B. So if A and B are the same identical matrix, then AB will be equal to BA. Okay. And the third condition, please note these conditions. You may get this as a question also. You never know in the exams. Be prepared to face all types of questions. Work hard, be confident, build up your speed, right? And be positive. This is how we approach. Okay. So third condition is when A is equal to B to the power n. Okay. If you know indices, right? A square, A cube, A to the power 4. If matrix A is B to the power n, or if matrix A is equal to matrix B, or if matrix A is equal to identity matrix, that means it is of the form 1001 or 100010001. In these three cases, AB will be equal to BA, right? Thanks to Rohit once again. Next is Madhusudan Kabra from Didwana. Can we add a square matrix and a rectangular matrix? I think we have got the answer as per discussion we had. No, you cannot add a square matrix and you cannot add a square matrix with a rectangular matrix because they are not of the same order. Okay, Swapnil Dixit from UP. Sir, please explain multiplication once again. Multiplication of matrix we will take. Today also we will go beyond 4 o'clock and continue. Right? A lot of things to discuss, and you can see continuously I'm taking up the exact questions which has come from different friends all over the country. So we will take some more time. Okay, Swapnil, I will take up multiplication after some time. Chavi Grover from Delhi. Sir, is unit matrix also known as identity matrix? Yes, Chavi, thanks for asking the question. Now, as per the discussion we had yesterday and now, you can understand unit matrix also means identity matrix. It is of the form 1001, 100010001. Next is Ritika from Chandigarh. Sir, please explain transpose matrix. Once again, I'll take transpose matrix. Okay. So let us take transpose matrix. See, this is a lot of this chapter, friends, a lot of new ideas we are getting, so many new terms we are getting. Matrix, array, then row matrix, then we had column matrix, then we had matrix addition, then we saw scalar matrix, diagonal matrix, then we had unit matrix, then we had AB and BA, commutative rule. So almost 14-15 new things. It will take some time to understand, and I'm sure you are there with me. We are learning together, and slowly things are coming in our control, in our grip, right? So just hold on and we will do it together. Okay, so the question has come that please explain transpose matrix. So A, okay, let's take a matrix here. So let me take a random matrix, okay. So 5, 4, 3, minus 1, 0, 9, 2, minus 7, 6. Now we are going to find the transpose AT, okay. AT means the transpose, okay. Like a merry-go-round. I go to that chair, you come here. I go to this chair, you come here. Exchanging position. Okay. So transpose matrix, how we do? Okay, let me use red color. So 4. See, the diagonal will remain as it is. No change in the diagonal. Okay. So what will happen is 4 will come here. So this 3 will go here. Okay. 2 will come here. Right. So what happens is this, that 5 remains here. Okay, 3 will come here. So 4 comes here. 4 is here in the row, but now it comes in the column. 3 comes here. 3 is in the row number 1. Now it comes here. So minus 1 comes here. 2 is in the column. It goes to the row. So 2 goes to the row. 0 is here. Right? Again, 9 comes here. And minus 7 goes here. And 6 remains as it is. Okay, so it is symmetrical, people from this side come to this side, right? People from this side come to this side, left to right, right to left, right? And keeping the diagonal as the axis or the center. Okay, so this is transpose matrix. And we will do it, we will do symmetric matrix and skew symmetric matrix, where this concept of transpose matrix will help you. Okay, thanks to Ritika for asking the question. Utkarsh from Lucknow, acknowledging you. Utkarsh has said that, sir, I really appreciate your thoughts. Thanks, Utkarsh. Next is Sri Priya from Kerala. Her question is only 3 by 3 matrix will come, or whether there will be 4 by 4 matrix. Now, I think if you go by the model test papers of the CA Foundation exam, mostly it is 3 by 3. I have seen 4 by 4 very rarely, but I would suggest you to be prepared with 3 by 3 and 4 by 4, but majority chance is 3 by 3 maybe coming in the exam. 4 by 4 is quite rare. Okay. Next, from Vadodara, we have a friend, Fatema Teli. He has asked the question, sir, I did not understand AB and BA, right? So the commutative rule, we have done it, but if time permits, I'll do again. If time permits, I cannot promise you, but definitely you have understood. I showed an example, and AB is not equal to BA, and Rohit from Jaipur asked the question, under what conditions AB is equal to BA? I give you the answer that AB is equal to BA under 3 conditions for your knowledge. First is when A is equal to B. Second is when A is equal to the unit matrix. And third is when A is equal to B to the power n. Okay, fine. Next is Soumya Jaiswal from Ranchi. I could not understand determinants. Answer, we will do again. Right. Idris from Devas. Please take Kramer rule. Yes, we will do Kramer's rule also. Urmila Bhagat from Dimapur. Kramer's rule, we will do it. Sajal Gupta from Kolkata. I am from Kolkata, so I have at least one friend from my city. Please explain scalar matrix and Kramer's rule. I think scalar matrix I have explained once again. Kramer's rule we will do today. Shrishti Gupta. She has asked a question regarding a particular determinant. I will solve it. Vanshika again has said that she has asked a question regarding a particular determinant. I will solve it once again for everybody. Devansh Afrikawala from Ahmedabad. So his asked question is, what is the exact difference between unit matrix and scalar matrix? So I think I've explained it. First we start with diagonal matrix, where all the numbers in the matrix other than the numbers on the diagonal are 0. And if all the numbers on the diagonal are equal, principal diagonal I am saying are equal, then it becomes a scalar matrix. And if this number is equal to 1, then it becomes a unit matrix, or it's also called identity matrix. So I think you got your answer, Devansh. Janavi from Gujarat. Sir, if a matrix is rectangular and not a square, then how shall we find its diagonal? Right. Now, ideally you will find that only a square matrix, this type of problems will arise in case of a square matrix only. Kushal from Moga. Is it compulsory to attempt the question paper in sequence? Well, no. You get the question paper, you can start doing those answers where you are confident. You can start with logical reasoning, question 1 to 100. So you can start from anywhere as per your preparation, as per your strategy. Okay, last 3. Kirtana from Chennai again. She has said, thanks for giving more confidence. Welcome, Kirtana. Annapurna from Chennai has said, thank you so much for making maths very easy. Welcome, Annapurna. Thanks. Thanks to all of you. Okay, so this was, the discussion based on the queries. Now, quickly, some of you said that yesterday I discussed about time management in the exam. How to tackle the question paper, in what sequence. I am repeating it once again. Now, you see, this exam time is basically your preparation, your time management, and your accuracy. So I would suggest, from my point of view, logical reasoning portion of our syllabus is very easy, right? So you get 20 marks, right? You can easily score 20. So you can start with that, number 1. Number 2 is move on to equations, simple equations, quadratic equations, indices, logarithms, ratios of proportion. This is the second part which you can complete. Next, you move on to AP and GP. Okay, so I'll just write it like this. It's there in the presentation. You will get it. I'm sure you have got and gone through the presentation of the last few days. So I'll write like this, a flow chart. First, logical reasoning. Then you move on to like AP, GP. See, I'm writing like a matrix. Okay, so AP, GP, then log. Okay, then equation, and then proportion, ratio, and proportion. So this is a matrix, dear friends. You can see this is a 3 by 2 matrix. 3 rows and 2 columns. So we are doing mathematics inside mathematics. So it is a 3 by 2 matrix. Fine. So you do this and then you can move on to the time value of money. Very important. Very, very important. I think thanks to the Institute for giving us 3 classes on time value of money. It's a very important chapter and a chapter where a lot of numericals keep coming and number of formula there. Shortcuts are there, but you have to remember many of the formula, right? So time value of money. After this, next what you can do is permutation and combination. And last, I think you can do set, functions, finally differential calculus and integral calculus. So this is a flowchart which is purely my personal interpretation, my personal approach, purely the way I see. If I am a student, if I am appearing for the exam, I will follow this path. Purely personal. Once again, I am saying I start with logical reasoning. It's quick. If I get the answers correctly, I build up my confidence. I boost my morale. I fight. And I have a calm mind because this is also the easiest part. I quickly go to AP, GP and equations and log and proportion, which is comparatively easier. Of course, here matrix is also included, right? Then I move to time value of money. Once I complete that, I go to permutation combination because here you have to think. Certain questions when we take this chapter, if I take this chapter later on, in case I take the chapter later on, or some other faculty takes the chapter, you will find that permutation combination is something where you have to exercise your brain. You have to think. Thinking means time taking. So I keep it later. And set and functions, not very difficult. You can handle it. Differential calculus, integral calculus will be a little difficult initially, but you have to remember many formula. So I'll keep it at the end. So number 1 is this. Number 2 is this. Number 3 is time value of money. Number 4 is permutation combination. Number 5 is sets. And the last is the calculus part. This is for the business mathematics part. Okay, fine. So with this, what I suggest is let us go quickly into determinants and Kramer's rule, and then we will do inequalities. Inequalities, linear inequalities, which is there in our syllabus, is not that, not much of tension. That I can assure you. Don't have any tension. Regarding no fear for inequalities. It's a small chapter, right? But determinants and Kramer's rule, we will take it first because our mind is fresh and I'm sure you have pen and paper with you. You are with me, connected. We are like in a matrix. We are together. We are arranged together, thinking together. So I'll first take up determinants quickly. Right. Now I have discussed about addition of matrices. We have done subtraction of matrices. I talked about the linear arrangement of rows, columns. I talked about the diagonal matrix. I talked about unit matrix, identity matrix. And let's upper triangle and lower triangle already done yesterday. Okay, equal matrices. Let me just take this one. Equal matrix. Just a moment. Okay. Now equal matrix, what is equal matrix? Equal matrix means that matrix where the order is same. Quickly I will cover this. Equal matrix. We only have little things left. Most of the things are done yesterday. So equal matrix. Question comes sometimes. So 2 conditions. Order of the matrix should be the same. 2 matrix should be equal if the order is the same and corresponding elements, the corresponding elements are equal. Okay, so please remember this. Now, the idea is if I write, for example, one matrix which is 3 by 2 and the other matrix considered having the same element is 2 by 3, then they are not equal matrix because corresponding elements may be same, but the order is wrong. Or maybe both of them are not complied with. So it is not going to be an equal matrix. Right. Now, one of your friends yesterday asked me a question, and he wrote a question. He said, "Sir, why are we learning matrix algebra? What is the use? Is it useful in business mathematics?" Because if you see the study material, the first page of your study material on matrix chapters, right, it is written that matrix algebra has uses in business, economics and finance. So this young friend, I am forgetting from which location, but I have his name in the list. Now he raised a query that what are the specific uses of matrix. Now you see, I will just write 4. We don't have much time, so we have to go ahead. I'll just write 4 uses. First is, many of you invest in shares. Many of you invest in mutual funds. Now you must be knowing there is something called portfolio. Portfolio is a group of shares. Portfolio is an array of shares. Okay, so you can construct a matrix of public sector company shares. You have say Steel Authority, Indian Oil, NTPC, State Bank of India, public sector company shares. They can form an array. They can form a matrix. Okay, so portfolio management is used. By matrix we do portfolio management. Secondly, you hear always whenever the advertisement of a mutual fund comes, what do they say? Mutual fund are subject to market risks. Please read the offer document before investing. So, mutual funds are subject to market risks. So, risk analysis is done using matrix. So, it's very, very useful. Please never think that we are just wasting time on matrix. No, sir. No, madam. This is very useful in CA. It's a tool which we use every day. But it's driven by software, but you need to know matrix, otherwise you cannot use the software, right? So in case of risk analysis, and also we use something called VAR. VAR means value at risk. Okay, so for portfolio selection, share selection, bond selection, we use matrix. Risk analysis, matrix is used, and also for calculating how much risk we use matrix. Okay, so thanks to our friend for asking this question. Right, I quickly now come to, linear combination. Okay, let me come to determinants. Yes, so we will take this determinants. Okay, now yesterday I did few determinants. We'll do many of them again quickly before entering into Kramer's rule. My target is to complete another 15 minutes. By 15 minutes we should be through, and then we start with inequalities, so that we will be able to complete inequalities today. And I will request you to be with me. We are extending the time, going beyond 4 o'clock, and making sure that we learn, understand and digest. Eating, digesting and remembering. Okay, that is how we have to make sure. Right, now we are taking a matrix A, B, C, D. Now it's a 2 by 2 matrix. 2 rows and 2 columns. Question is, the determinant of this is called det. Say this is A, okay, matrix A. So we call determinant A, or sometimes delta A, whatever. But the formula is cross multiplication. AB minus BC. Okay, so this is for a 2 by 2 matrix. But for a 3 by 3 matrix, I discussed yesterday, I did one numerical. It is a bit difficult. But first let us do some examples of determinants. Please do with me. I think you have pen and paper with you. Let us do it together. Right. So the first determinant I am taking quickly is 1, 2, 3, 4. Short, simple and sweet. 1, 2, 3, 4. Okay. So what to do? Cross multiplication. Please do with me. Okay. So 1 into 4. 1 into 4 minus 3 into 2. Okay. Or 2 into 3. Whatever. So we have 4 minus 6. So the answer is minus 2. Yes, it is as simple as that. You get full marks. Okay. First example, I think clear. Okay. We move forward. The next one, a bit tough. Okay. Next example. Determinant matrix D is equal to 4 minus 3, 3 and minus 5. What to do? Okay. Please think. Formula is same. AD minus BC. AD minus BC. So what do we do? A into D. So 4 into minus 5. Okay. Minus this into this. So minus 3 into 3. Please follow step by step. I'm going slow, right? No point going fast and showing I know so much. No, we have to go slow and make sure we all understand. Okay, so the rule is this and this and this product. Okay, so 4 into minus 5 is minus 20. Minus, this minus comes here. Okay, and within the bracket it is minus 3 into 3. Okay, so it is minus 9. So you get minus 20 minus of minus 9. So minus and minus makes plus. So it is minus 20 plus 9, that is minus 11. Okay, so I think it is clear, right? Minus 11. Okay, so slowly 2 by 2 determinants, 2 by 2 matrix, we are finding determinants. Okay, I'll give one more example. Rubbing out. The more we do, the more confident we become and we lose the fear. Fear is very bad. I always say that don't have fear, virtual class is here. Okay, so forget the fear, forget the panic, be focused, right? And work hard every day, little by little. The fundamental accounting assumption is consistency. Every day you follow and practice consistently. And there is another accounting assumption, going concern. So if you do everything consistently, every day 10 problems, every day 2 hours of study, 3 hours of study, then you will always be a going concern. Never forget that. Okay, right. So let's do the other one. This matrix, let's call it X. Okay, X all negative. I'll give all negative here. Minus 5. Okay, minus 5, minus 4, minus 2 and minus 3. So you have to find the determinant of this matrix. You see similar questions come in the exam. Don't worry. Questions of this standard comes in the exam also. So you have to find the determinant of X. Of what? The formula is this multiplied by this. Okay, let us write. So it is, I'll use blue color please. Yes. So minus 5 into minus 3. Minus 5 into minus 3. Got it? Okay, this is first group. Minus. Now you have minus 4 and this minus 2. Okay, so you have minus 4 into minus 2. Please do step by step with me. Okay, you're following, I hope. Audio video is fine, right? Occasionally you see we may have network issues. It can happen from my side. It can happen during the transmission. It can happen in your side also, because many of you might be using mobile phones and sometimes the network is weak. Plus another point, please remember, dear friends, now 50% of India is working from home. Okay. So with so much of load coming on the bandwidth, right? So network is bound to suffer. 50% people are using broadband from home. Therefore, whether it's Airtel or Jio or Vodafone or whatever company, the service quality will always, it cannot be consistent continuously. So you may always, out of 2.5 hours of lecture or 2 hours of lecture, 5-10 minutes here and there, it can always happen. That we have to accept. Seamless 24/7, continuous net, continuous same level we don't get. Plus, please, this video is going for live streaming. Don't forget that. So therefore, sometimes there may be small problems, but we have to adjust it, right? Okay, so now you have this determinant, minus 5 into minus 3, minus 4 into minus 2. So, first part, minus 5 into minus 3 is what? Minus and minus becomes plus. So, it is 15. Minus Minus 4 into minus 2. Minus and minus gives you plus. So it is 4 2s are 8. So the answer is 15 minus 8, 7. Okay? As simple as that. This is the right way to do it. Okay. Now we will try let's try 3 by 3. Okay. So we are going slowly up. So first 2 into 2. Now 3 into 3. Right? So we take a 3 by 3 matrix. Let's call it X. X is equal to 2 minus 1 6 minus 3 4. Let's take minus 5. Then we have 8 minus 7 and minus 9. Okay. So let us try to find the value of this, the determinant of X. So I am writing determinant of X. Please note, dear friends, this is the last example. Let me see if I have further examples. Maybe one more if I find time. We will quickly go into Kramer's rule based on this, and then we move into inequalities. By 3:30, we will start with inequalities, in linear inequalities, and we will try to complete it. Expected time of completion is around 1 hour, right? So it will take 1 hour. Okay. So now we move on to the solving part of this determinant, and the matrix is X. Okay. So please note down this matrix 2 minus 1 6. So we have 2 minus 1 6 minus 3 4 minus 5, and then you have 8 minus 7 minus 9. Okay. So let us remember the rule. First we take 2. This is A1, A2, A3. Okay, don't forget that. So A1, A2, A3. So the rule is first we take A1. So here it is 2. Multiply. Once you take this, now you have to consider this part. Okay. So what will happen? So it is B2C3. So 4 into minus 9. Be very careful. This is a tough example, and determinant is something where one mistake here and there makes the entire number, the numerical goes wrong. So let us do step by step with a cool mind. 4 into minus 9 minus, you have minus 5 into minus 7. This is the first part. Now you have A2, and we know that the sign before A2 will be negative. A1, B2C3 minus B3C2 minus A2. So I write minus, but there we have minus 1. So minus of minus 1. Now we open the bracket. So now we are considering this part. So we will take which numbers for this cross multiplication? This and this and this and this. Okay. So the 4 numbers in the extreme. So minus 3 into minus 9. So I will write minus 3 into minus 9 minus 5 into 8. So minus 5 into 8. This is the second line. And the third line is plus A3. So I am writing here plus A3 is 6. So plus 6. So I will now take this part. So it is minus 3 into minus 7. So minus 3 into minus 7 minus 4 into 8. 4 into 8 is 32. 4 into 8 gives you 32. So I will write 32. Okay. So let us see whether we are correct. 2. This is the last example on determinants. So please, and 3 by 3. So we have done number of examples on 2 by 2. This is 3 by 3. So A1 is 2. I am ticking off. 4 into minus 9. 4 into minus 9 is done. Minus of minus 5 into minus 7. Minus 5 and minus 7 is done. Negative sign is given. Then you have minus. This minus 1 comes here. Minus 1. Minus 3 into minus 9. Minus 3 into minus 9. Minus 5 into 8. So we are taking the diagonal. Minus 5 into 8 is done. Plus 6. This 6 comes here. minus 3 into minus 7, minus 3 into minus 7, minus 4 into 8, minus 32. Okay, let us slowly simplify. It's a long, expression. Let us simplify and see what happens. Okay, please do with me. You may get the answer before me. I am going slow because I am explaining. Right. So. Okay. So let me wrap up this part so that we can work. Okay. We will solve this. So, solving this. 2. 4 into minus 9 is minus 36. Minus 5 into minus 7. Minus 5 into minus 7 is 35. Minus and minus becomes plus. So it becomes 35. So 35. Okay. So first part is over. I rub out. I just cut across. Second line. Minus of minus 1. Now we open the brackets. Minus 3 into minus 9. Minus 3 into minus 9 gives you 27. So minus 3 into minus 9 is 27. Minus 5 into 8. Minus 5 into 8 is minus 40. So this is minus of minus 40. Okay. Now we rub out, okay. Now the last line is plus 6. Within bracket we have minus 3 into minus 7. Minus 3 into minus 7 is 21. Minus minus becomes plus. So it's 21. Minus 32. Okay. Now we rub out this part so that you can write. Okay. So minus 36 minus 35. Minus and minus is minus 71. Minus 71 into 2 is minus 142. So 71 into 2. 2 ones are 2, 2 sevens are 14. Yes, minus 142. Okay, first part. Minus of minus 1, you have 27 here, 27, minus of minus 40. So it becomes 27 plus 40. Okay. So this part is done. And last part is plus 6. 21 minus 32 is how much? 21 minus 32 is minus 11. Okay. So this is minus 11. So now the expression is minus 142. This minus and minus becomes plus. Plus 27 and 40 is 67. And here you have minus 11 into 6. Minus 11 into 6 is minus 66. So you have minus 66. Okay, so it is, you can see we are taking steps, slow steps, okay, but slow and steady. So you have minus 142 plus 67 minus 66. Minus 142 plus 67 minus 66. 67 minus 66 is plus 1. So you have minus 142 plus 1, that is minus 141. This is the answer. Please check. I hope you have done the numerical with me. You have done the numerical. The answer is minus 141. Okay. Okay. Perfect, on time. Now we move to Kramer's rule. Okay. Right. So with this knowledge of matrix and determinants, it is enough to move into Kramer's rule, one of the very interesting and shortcuts to solving numerical problems. Okay. Now, the Kramer's rule, has two parts. One part is, the rule is the same, but we can apply it for solving two types of equations. First is equations with x and y, that is two unknowns, and equations with three unknowns, x, y and z, right? So first let us write what is the formula for Kramer's rule. So please write with me Kramer's rule. Okay, so we have completed matrix, we have completed determinants. Okay, be sure, be confident, be strong, be focused. Now Kramer's rule, then inequalities. Then we'll complete today. Okay. So Kramer's rule, if I write two equations, you know the form of an equation. A1x plus B1y is equal to D1. So AX plus BY equal to C. It is the form of a linear equation. The power of x is 1. So it is straight line, linear. Okay. The other equation is A2x plus B2y equal to D2. Okay. Now, how to solve for x and y? Now, you have learned elimination method, substitution method, simultaneous linear equation, but now new technique, Kramer's rule. Well, sounds great. Kramer's rule. What is Kramer's rule? Okay. So what we do is we have to find determinants, right? So what we write is the value of x will be, so you have x and y, these are the unknowns, two unknowns here. Okay. So you have two unknowns and you also have two equations, right? So x and y are the unknowns and you have equation 1 and equation 2. We know different techniques of solving, but we will use Kramer's rule. Now Kramer's rule says that x is equal to, please note carefully, in place of a1 and a2. Okay, we will cover it and bring d1 and d2 here. Okay. So, the determinant will be, x will be determinant of x by determinant. Let me write first. You'll understand. We are taking x first. Okay, then we'll learn y. Determinant of x means, in place of a1, a2, we will have d1, d2. So, we will get a matrix d1, d2 and b1, b2. See if this is clear. We want to find the value of x. Step number 1, shortcut. Many of you were asking for shortcuts. This is shortcut. So quickly, I have to understand. X, I have to find out. So A1, A2, remove. Eliminate. D1, D2, you bring D1 in place of A1, D2 in place of A2. Right? So you have D1, D2 and B1, B2. This becomes a matrix. Fine? And you now know how to find out the determinant of this matrix. So basically we have to find the determinant of this matrix, and in the denominator, it will be the normal matrix. What is the normal matrix? A1, A2, B1, B2. So here A1, A2, B1, B2. As simple as this. If you understand this, you will also understand Kramer's rule for solving three equations. Right? So we have to find two determinants. Okay? So this is what we do for x. So D1 comes in place of A1, D2 comes in place of A2. So you have D1, D2 here, and B1, B2 as it is will come here. This is for finding determinant of x, and for the actual determinant, main determinant which will come in the denominator, it is A1, A2, and B1, B2. Okay. Now for y, what will be the equation for y? I am writing it here. Y will be what? Determinant of y divided by this determinant. Okay. Divided by this determinant. That means this one. Determinant y, what will happen? In place of B1, B2, just move D1 and D2. Okay. It's just shifting. Shifting from one seat to the other seat. Shifting from one place to the other place. So this will be determinant of A1, A2, D1, D2. This is in the numerator, and in the denominator it will be A1, A2, B1, B2. This is Kramer's rule. As simple as that. We will do with an example. It will be easy now. Okay. So let's take an example. Whatever we have learnt, keep it in mind. So that's why you see Kramer's rule is the height of matrix chapter. And in order to understand Kramer's rule, we have to understand matrix first. Okay. All types of matrix. Then we learned what is determinants. Okay. After learning determinants, and after handling determinants for 2 by 2 and 3 by 3, now we are in a position to move into matrix, that is Kramer's rule. Okay, so everything is step by step. So this is the formula. Now we will take a numerical. Okay. Right? So in this way we are making sure that we are following each and every chapter step by step. No hurry. If necessary, we will take extra time. Right? And make sure that our learning is complete. And no gaps. Okay. So I'm taking two equations, Kramer's rule. First, I'm taking 3x plus 4y. Okay, let me write from this side. 3x plus 4y is equal to minus 14. First equation, please write with me. 3x plus 4y equal to minus 14 and minus 2x minus 3y is equal to 11. Okay. This is Kramer's rule. We are applying Kramer's rule to solve these equations. Of course, you know techniques of solving equations. This is easy now for you. You can use substitution, elimination, etc. But now we will use Kramer's rule. So what do we do? How to find the value of x? Please follow very carefully. My request to you, please follow very carefully. Okay? Because in the last, what I wrote in the last, the last occasion, that was a formula. Formula normally is difficult to remember. But the moment I use numbers, your brain will pick up the logic, isn't it? So let's learn through numbers, okay? So x will be equal to determinant of x by determinant. Okay. Now let us find this one first. So y again will be determinant of y by determinant. Let us find this determinant. This determinant is what? Just create the matrix 3, 4. So I write 3, 4. Minus 2, minus 3. Okay? A1, A2, B1, B2 like that. So it is minus 2 and minus 3. Done? Okay. What is the value of this determinant? You know, if it is A, B, C, D, then it is AD minus BC. So this minus this. So the value is 3 into minus 3. Minus 4 into minus 2. Minus 4 into minus 2. So this is minus 9 minus of minus 8. So it is minus 9 plus 8, that is minus 1. So the denominator is minus 1. Okay? So we are just taking 3, 2, 4 and minus 3. I hope it is clear. You are following? Now we have to find what is determinant x. So what is determinant x? Right. Now determinant x, you know, will be, in place of 3 and minus 2, we will take these two numbers, minus 14 and 11. Okay. So the determinant will be minus 14, 11 will come here, and 4 and minus 3. So 4 and minus 3. This is the numerator, and denominator we have found is minus 1 already. So let us see what does this mean. Minus 14, 4, 11 and minus 3. This is a matrix, 2 by 2 matrix, right? What is the determinant? This minus this. So minus 14 into minus 3. Minus 14 into minus 3 is 42 plus 42. So it is 42 minus 11 into 4. 11 into 4 is how much? 44. Okay. So 42 minus 44. That is minus 2. So we have solved it. As simple as that. X is equal to determinant x. That is minus 2 divided by determinant. The determinant we have done minus 1. So minus 2 by minus 1, which is equal to minus minus cancels, it is equal to 2. So x is equal to 2. Okay. This is how Kramer's rule is used. Now y. Okay. Since it is the first example, I am doing it. But from the next example, I will request you to work out independently. Always try to be independent. Try to help yourself. Okay. Now I will solve again for y. Okay. Now y, what will happen in case of y? So in case of y, delta y, that is determinant of y. What will be the matrix? 3 and minus 2 will be there as usual, 3 and minus 2. But in place of 4 and minus 3, it is 4y minus 3y. In place of 4 and minus 3, we will have minus 14 and 11. Okay? So it will become minus 14 and 11. Okay? Now we have, so the matrix is 3, minus 14, minus 2, 11. So what will be the, if you cross multiply now, 3 into 11, 33, minus 14 into minus 2. Minus 14 into minus 2 is 28, right? So 33 minus 28. This is equal to 5. But in the denominator, so the numerator is 5. Delta y, determinant of y is 5. Okay? This 5 is here, comes here. But in the denominator it is only delta, and only delta is minus 1. So the answer y is 5 by minus 1. Somebody asked, can we have a negative number in the denominator? Yes, we can have a negative number in the denominator. I think somebody asked me, I was going through almost 250 queries for the first day. So 250 queries, one of them asked. Right, so it's good that I would answer back. So 5 by minus 1 means minus 5. So the solution is x is equal to 2 and y is equal to minus 5. If you put 2 here, so let's see whether this is correct or not. This is Kramer's rule. It's something new you have learned. Determinant of x by determinant gives you the value of x, and determinant of y by determinant gives you the value of y. Now let's put 3 into 2 is 6 plus 4 into minus 5 is minus 20. So 6 minus 20 is minus 14. So this equation is correct, satisfied. Next one, minus 2x, x is 2. So minus 2 into 2 is minus 4. Minus 3y, y is minus 5. So minus 3y becomes plus 15, right? So minus 4 plus 15, which is 11. So second equation is also correct. So we have been able to satisfy both the equations, right? Both the equations using Kramer's rule. Okay. Now we will take another small equation quickly using Kramer's rule. We just have 2 minutes or 3 minutes to move into linear inequalities. Okay. So I'll take quickly, we'll take a small one. 5x plus 2y. Just solve for x. This time I'm not going into solving y, just x. 5x plus 2y equal to 16. Okay, and 3x minus 5y is equal to minus 9. You have to solve for x. Okay, so what we do? We know that x is equal to determinant of x by determinant. This determinant is equal to 5, 2, 3 minus 5. 5, 2, 3 minus 5. Okay? 5, 2, 3 minus 5. Please do with me. 5, 2, 3 minus 5. Right? So, if this is the determinant, fine, we have to find the value. This is equal to 5 into minus 5. Cross. So, minus 25. Minus 3 into 2 is 6. Okay? So, minus 25 minus 6, which is equal to minus 31. So, denominator we know is minus 31. Now, we have to find the numerator, which is delta or determinant of x. I am rubbing this part. We will work this. We have already got the value. Do we find determinant of x? Determinant of x means instead of 5 and 3, put 16 and minus 9. So the matrix is 16 minus 9 instead of 5 and 3. Keep 2 and minus 5 as it is, right? So the idea is to pick this, put it on x, right? In Hindi we say chipka dijiye. Okay. Taking up, pasting it. When we want to find the value of x, when we want to find the value of y, isko uthaiye, you pick it up and paste it on y. Okay. This is how. So 16 and minus 9, now we are doing for x. So instead of 5 and 3, we will have 16 and minus 9. Instead of 2 and minus 5, 2 and minus 5 will remain. So 2 and minus 5 remains. So the value will be how much? Denominator we have already got, minus 31. What is the value of this? 16 into minus 5. 16 into minus 5 is minus 80. Minus 2 into minus 9. Minus 2 into minus 9. So minus 2 into minus 9. So it is minus 80. Minus and minus becomes plus. Plus 18. That is minus 62. Minus 80 plus 18 is minus 62. So the numerator becomes minus 62 and the denominator is minus 31. So minus and minus cancels out. The answer is 2. 31 2s are 62. So we have solved for x. X is equal to 2. So this is Kramer's rule. Similarly, you can use Kramer's rule also for three unknowns x, y and z. The equation will be the same. In place of x, it will be d1. Like here it's d1, d2. It will be d1, d2, d3. In place of y, if you want to find the value of y, the equation will be basically we have to find the determinant a1, a2, a3, d1, d2, d3 and c1, c2, c3. So this will go in place of y. The principle is same and we have already done determinant using 3 by 3 matrix. So calculation also will not be difficult for you. Okay. So we have done Kramer's rule and we have also done Kramer's rule for the two variables. We have used multiple examples and now advantages of Kramer's rule, last but not the least. We are completing the chapter matrix, determinants and Kramer's rule. So in case of Kramer's rule, of course, the idea is, it's a shortcut sometimes. It's a shortcut. Today at the end, if I get some more time or maybe I keep it for the next day if possible, we will, if later on we'll do an exam question on Kramer's rule involving three unknowns. If possible, we'll do it, right? And because now we'll have to move into linear inequalities, right? So advantages of Kramer's rule, sometimes it is a shortcut, right? Disadvantage is for a 3 by 3 matrix, the determinant calculation is complex, especially under exam conditions. Keeping your cool, you have to maintain your calmness. You have to maintain your cool and be like Captain Cool, right? You have to maintain your cool mind and then you have to work on determinants because 3 by 3 determinants, Kramer's rule comes in the exam. Okay, so we will do a 3 by 3 later on because it will take a lot of time. Step by step if I do. I will just take a small example on cubic equation. Some of you wanted me to do a small cubic equation. So just give me a moment. Let me do a cubic equation. So many things to do. Okay. I'll take one cubic equation. And then we will complete and move into linear inequalities. Okay. So we have done a lot of things today. Okay. Now, I'll take a cubic equation, x cube minus 6x square, okay, plus 11x minus 6. This is from your study material. So, I will write the page number. Please note, the page number is 2.26. Okay, page number 2.26. Unit 1 and exercise 1. Okay. Page number 2.26, unit 1, exercise 1, and this is on cubic equation. Okay, cubic equation. Okay, so please note this problem. X cube minus 6x square plus 11x minus 6. Okay. Please note and write this equation and we will use trial and error to see whether you know that you have to use trial and error to find out whether x equal to 1 makes this 0. Okay, because the equation is given x cube minus 6x square plus 11x minus 6 equal to 0. Okay. Okay, so please put x equal to 1 and see. Trial and error. Many of you wrote in the comments, in the ECPL's query website, query site, that sir, can you do one cubic equation? Please do a cubic equation. Okay, fine, we'll do it. We are doing it now, right? So I am handling almost all the queries. I spoke individually about all of you and responded to your queries. So let's do this. The last one before we move into linear inequalities, right? So this, if you use x equal to 1, trial and error means you have to first x equal to 1, you have to try. If does not work, if the left hand side does not become 0, then you have to try x equal to -1. If it does not work, if it is negative, if it fails to bring it to 0, you have to assume x equal to 2. If this also fails, x equal to -2. If this also fails, x equal to 3. Of course, not to worry. This will not come to this extent. Normally, these three, either x equal to 1 or x equal to -1 or, basically what will happen is 1, -1, 2 and -2. Maximum it will go till this. Right. So can you try with x equal to 1? Okay. What happens? 1 x equal to 1. So x cube is 1 cube. Okay. Minus 6x square. 6 into 1 square. 6 into 1 square. Okay. Plus 11x. Plus 11 into 1 minus 6. Let us see if it is 0. Okay. So 1 cube is 1. Minus 1 square is 1. 6 into 1. So it is, we have x square minus x cube minus 6x square plus 11x minus 6. Okay, so 1 square is 1. 6 into 1 is 6, sorry. 1 minus 6 plus 11 into 1 is 11 minus 6. So you have 1 plus 11 minus 6 minus 6. So it is 1 plus 11 is 12 minus 6 minus 6 is 12. So it is 0. Okay. Putting x equal to 1, the expression becomes 0, which means x minus 1 is a factor. Okay. Always remember this simple formula or simple idea. If x equal to a makes the equation 0, okay, please write it or take a snapshot. Oh, of course, you'll get the video uploaded in YouTube. So if x equal to a makes the equation 0, then x minus a is a factor of this, right? This is the golden rule, or this is the working rule for cubic equation. As simple as that. Now, rest is just, cakewalk. Okay, now we'll do it. So here we saw that for x equal to 1, this is an exam problem, and please note this is from the study material, and it's an important question. And if you can do it, you can do other types of cubic equations easily. So x minus 1 is a factor. Fine. So I will write x minus 1, x minus 1, x minus 1. Okay. Now I have to multiply x minus 1 with something so that I get this. Now first term I have is x cube. Please pay attention, dear friends, dear students, pay attention and learn, understand this. This is work, this is the time, thinking. You have to think. What, in order to get x cube, you have x minus 1. So you should multiply x minus 1 with what? To get x cube. It has to be with x square. So I write x square. If I write x square, it becomes x square into x cube minus x square. But here we have minus 6x square. I have got minus x square. I need minus 6. So I have got 1. I need 6. So I have to increase it by 5. So minus x square, I have to now go for minus 5x square. How will I get this 5x square? By multiplying the x minus 1 again by 5x. So I get minus 5 into x minus 5x square. So now I have got this part, I have got this part. Right? Now, the moment I have multiplied x minus 1 with 5x, minus 5x, I have got minus 5x square. Plus, minus and minus becomes plus. Plus 5x into 1, which is 5x. But I need 11x. I have 5x. I need 11x. So I have to increase by how much? 6x. 5x and 6x gives you 11x. I have got 5x. I have to increase it by 6x so that I get 11x. How to increase it by 6x? I have x minus 1 here. So I will just add plus 6. So this becomes 6x plus 6x. And 6 into minus 1 is minus 6. So we have got 11x also, minus 6 also. As simple as that, right? Looks difficult, but it is not difficult. Just a little bit of common sense. So now we have got the equation x minus 1 is a factor. X minus 1, x minus 1, x minus 1 is one of the factor. The other factor is x squared minus 5x plus 6. So x squared minus 5x plus 6. If you break this one up, alpha plus beta equal to b by a minus b by a, alpha beta equal to c by a. It's a quadratic equation. If you break this up, I'm doing it, no problem. Let's complete so that you have no queries, no doubts, right? So x square minus 5x plus 6. The second factor, if I break it, 3 into 2 is 6, right? This 6 I'm getting. 3 plus 2 is 5, okay? So what I'll do, x square minus 3x minus 2x plus 6. Minus 3x minus 2x gives you 5x. So this becomes x minus 3 minus 2, x minus 3. So we get x minus 3 and x minus 2. Here we got x minus 1 already. So the complete factors are x minus 1 into x minus 2 into x minus 3. This is the solution, which means x is equal to 1 or 2 or 3. Right? X minus 1 is a factor means what? X is equal to 1, then it becomes 0. X minus 2 is a factor. So if x is equal to 2, 2 minus 2 is 0. The full expression becomes 0. And x minus 3 is a factor, which means if x is 3, 3 minus 3 is 0. So the full expression becomes 0. Okay? This is how we break cubic equations into quadratic and simple, and then we again break the quadratic equation and we get these solutions. So dear friends, with this we come to the end of this chapter on matrix and matrix determinants and Kramer's rule, and now we start with linear inequalities. Okay, so I'll rub it up. Please have pen and paper with you, and we move into linear inequalities. Okay. Okay. So we have learned a lot about equation now, right? So it's time for linear inequalities. Okay. So, common example. Okay. So, which is more difficult? IPCC exam or foundation? Difficulty of IPCC exam is more. Okay. So, we write IPCC is greater than foundation. Can we write? Yes? Okay. Second example, say, World Cup. Right? Winning the World Cup and winning the national sports medal. Which one is bigger? World Cup. World Cup is bigger than being a national champion, for example. Okay? World title is bigger. So, inequality talks about two things, greater than and less than. Okay. Till now we have only seen equality sign, but now it is inequality, which means a relation between two objects, a relation between two numbers where one is greater. So, I can always write 100 is greater than 70. 65 is less than 90. Okay. So, inequality, but it's a relation. Father's age is always greater than son's age, right? For example, the salary which a CA earns at the age of 40 and a CA who has just qualified at the age of 22, salary S40 will always be more than S22. Salary of a person CA at 40 years of age will always be more than a salary of a fresher. So this is inequality, and we also need to do some graphical work here, because in inequality chapter we have graph. Otherwise, the chapter is small and easier than equations and this matrix, of course. I should admit that. That's why I have kept it at the end. Matrix, determinants, and Kramer's rule is no doubt is difficult. I respect it. You have to call a spade a spade. It is not a joke. It is not that easy, especially 3 by 3 determinants and the way A, B and B, A, these things are difficult. At least more difficult than inequality. That much is sure. But I think now you are happy because we have done in-depth analysis of matrix and determinants, and we have whatever with the time we went beyond the time limit and we covered more. We were given 2 hours, but I covered 2.5 hours. Went extra so that we can cover more material and more examples, right? So now let us go to inequality, and what happens is first thing they give you in the exam is 2 types of problems. One is graphical problem and the other one is creating equations, inequations, right? Out of given data. Like we were given a data, digit, okay, so units place, tens place, or father and son's age. You remember in equations? So here you will be given situation, you have to form inequation, not equation, inequation. Okay, so let me take an example of that first, and then we will do the graph, right? Okay, so let's take the first example, A. I request you to open your study material, page 3.6. Page 3.6, we are doing the study material example first. Now, a manufacturer produces 2 products A and B, and there are 2 products and he has 2 machines, right? 2 machines and 2 products. Now, 2 products A and B. So, and machine 1 and machine 2. So, 2 products, 2 machines, right? We have to form very similar to equations, inequations, right? Okay. Now, you know these terms. If I say that I must get at least 40. If I say I must score at least 40 in the exam. That means if I get 39, it's not done. I have not fulfilled the condition. So if I say I must get at least 40 in mathematics paper, right, it means that my score should be 40 and above. Okay, if I say that, oh, I will get maximum 70, it means my score will be 70 is the limit. So up to 70, I can get 68, I can get 62, maximum 70. Okay, so from this, we have the concept of greater than equal to sign. If I say that I must score 40, otherwise gone, I am failed. I'll fail in the exam. My God, so much of effort, so much of time, parents, friends, relatives, everybody knows I'm appearing for CA Foundation. My first attempt, I have to make it. Okay, I must get at least 40. So, the equation should be if X is your marks, X at least 40 means you should score greater than equal to 40. Minimum is 40, but you should score more. At least 40 means 40 and above. Okay. So if I say that, oh, my accounts paper was too good, terrific. Oh, I'll get up to, 65. So it means my marks in accounts is Y. So my score is, I'll get up to 65, maximum is 65, but I might get less than 65 also. So this is less than equal to sign and this is greater than equal to sign. Okay? I hope you're understanding. Right. So let's see the example. So the question is, company has 2 products A and B. I hope you have opened that example and it has got 2 machines, M1 and M2. And it is in operation for 24 hours in a day. Now production of product A requires 2 hours of processing. 2 hours of processing in machine M1 and 6 hours in M2. So to produce 1 unit of product A, you need to process it for 2 hours in machine 1 and 6 hours in machine 2. Right? And right, so the idea is, okay, the idea is that what the manufacturer, yeah, and of course product B, what does it require? Please say the example. It requires 6 hours of processing in machine 1, and it requires 6 hours in machine 1 and 2 hours in machine 2. So it is 2, 6 and 6, 2, just a reverse, right? So 2 hours in machine 1 and 6 hours in machine 2 for product A, and for product B it is 6 hours in machine 1 and 2 hours in machine 2, and the manufacturer earns a profit of 5 units, 5 rupees on each unit of A. So the profit is per unit is rupees 5 for A and rupees 2 for B. How many units of each product should be produced in a day? Please note that his machines are in operation for 24 hours. Okay, the machines are in operation for 24 hours. And what are the inequations, or what are the constraints? So we call it boundary constraints, right? Even if you work hard, you say in a post-graduation exam, possibly you cannot score beyond 90. Just to give an example, 90 is the outer boundary, right? So similarly, if you really put in hard work in CA Foundation, you may not score below 50 if you really put in hard work. So lower boundary is 50, and so these are bounded examples of boundaries, right? Now here you can see the upper boundary is 24 hours. Machines are working for 24 hours. Okay. Now we are assuming that they are producing product A and B. We are assuming that number of units of product A is X, okay, X1, and for B is X2. So the company is producing X1 units of product A and X2 units of product B. It has 2 machines, M1 and M2, and for production of A, it requires 2 hours in machine 1 and 6 hours in machine 2. And for product B, it requires 6 hours in machine 1 and 2 hours in machine 2. Okay, so we have to, basically what we have to do is we have to increase somehow the revenue of the person, because he is earning 5 units per 5 rupees per unit of the product A and 2 rupees per unit of the product B. Okay, so you can understand, if he is earning 5 rupees for one product of A, then his profit, if he produces X1 units, he is earning 5 rupees per unit. He is producing X1 units. Okay, so his profit is 5X1, 5 rupees for 1 unit. For X1 units, 5X1. I hope this is understandable. And for product B, he is earning 2 rupees per unit. 2 rupees per unit. Okay. And he is producing X2. So his profit on product B is how much? 2 rupees per unit and X2 units, so 2X2. So his total profit, if I write Z, is equal to 5X1 plus 2X2. I hope this is clear, right? 5X1 plus 2X2. Okay. Right? 5X1 plus 2X2. So this is Z. Now, you see, this is a type of problem which when we were students, long back, I passed almost 20 years. Now, when we were students, we had a chapter called linear programming, and there, these type of problems used to be there. It is called optimization problem, right? Or we have to maximize the profit. So the solution will be, the first point you have to write is we have to maximize. You have to maximize this Z equal to 5X1 plus 2X2. This is the first objective. Okay, this is the first target. Now the question is, the next target is X1 is is what? The number of units of product A. So you can easily understand X1 means actual production. Okay. So what is the lowest number of actual production? 0. Okay. So we can easily understand X1 will be greater than or equal to 0. Similarly, X2, which is the number of units of product B, 20, wrong answers or 30 wrong answers. So I end up getting negative marks. Just to give an example. But in case of production cannot be negative. So production, the minimum is 0. During lockdown, 0 production. During COVID-19, factory is down, all the machines are off, so 0 production. But production can never be negative. So X1 is greater than or equal to 0, the floor is 0, minimum 0. Greater than or equal to 0 means what? 0 and above. X2 is also greater than or equal to 0. So we have got two conditions. First is we have to maximize the profit. In economics, you have learned about profit, you have learned about revenue, you have learned about the cost function. So you know 5x1 plus 2x2 is the profit function, and you also know that in commerce, in financial terms, the objective of every organization is to maximize the profit. Okay, profit maximization principle. So this is 5x1 plus 2x2 is the profit function, and we are trying to maximize it. Okay, this is done. Second condition is what? Yeah, x1 cannot be negative. X2 cannot be negative. That means the number of products of type A and B has to be positive. It cannot be negative. So x1 is greater than or equal to 0. X1 is greater than or equal to 0. X2 is greater than or equal to 0. Okay. Okay. Now we have to see the next question. That is, let us now see, just rubbing this part. Okay. Okay. Right. Okay. So now the question is, you see, the product requires how much? 2 hours on machine 1 and 6 hours on machine 2, and we are producing X1 units of product A. Okay. X1 units of product A and X2 units of product B. So if you look at machine 1, first machine, what is the total load on machine 1? What is the load? Like you have 4 loads: accounts, mathematics, economics, law, right? Overburdened with studies, right? So what is the load on machine 1? So it has to handle both A and B, product A and B. Okay, and X1 units of product A is produced. For 1 unit it is 2 hours. So for X1 unit, how much time? 2x1 hours. For 1 unit of B, it takes 6 hours. For X2 units, it will take 6x2. So the total hours for which machine A will be running, okay, is how much? 2x1 plus 6x2. So this is the time. See how we are framing the equation. Okay. So it is 2x1 plus 6x2. Right? But already it is given here that the machines are running for maximum for 24 hours. Do you have more than 24 hours in a day? No. For us it is 24 hours. For a celebrity it is 24 hours. For a baby, newborn baby is 24 hours. For a 90-year-old person is 24 hours. You cannot increase it. Ceiling is 24. Okay. So 2x1 plus 6x2, which means the total amount of, you can say the total production, right, which I am taking place, the total amount of time, if you see, ultimately is what? Has to be less than or equal to 24. So the equation is 2x1 plus 6x2 is less than or equal to 24. It can at best, at maximum reach 24 hours, not less than that. So this is for machine 1. For machine 2, what will happen? 6 into x1. So the time taken will be 6x1 plus for product B it is 2x2. So plus 2x2. Again this will be less than 24. Less than equal to 24. See this less than equal to sign everywhere. This shows that this is not an equation but inequation. It has to be less than equal to 24. It can be less than 24. Total time taking can be 18 hours to produce both product A and B. X1 units of A and X2 units of B. It can maximum be 24 hours, not more than that. So it's a ceiling. We talk about a floor and a cap. Floor means the lowest, threshold, floor. What is the floor height? And the height. That's the, you can call it the cap or the ceiling height. Okay. So here you see both the heights are given. So ultimately if you see the solution, right? So we have 4 conditions, you can say. First condition we did is this one. You have to maximize the profit, number 1. Next we had that production X1 should be equal to greater than equal to 0. X2 should be greater than equal to 0. So this is the second one. 2x1 plus 6x2 should be less than equal to 24. This is the third one. I'm writing 3. And 6x1 plus 2x2 again less than 24. This is the fourth one. So 4 conditions are met. So this is how we create the inequations, and again there is a system by which we can graphically draw it. You know, x-axis, y-axis. We'll do that after some time. Okay. Now I go to another example. I will request you to move to page 3.8. Okay. So I hope now this is not a very difficult chapter and not much of formula to remember. Just concept. Okay. Not much of formula to memorize and mug up and complicating things. But this is, if you understand equations, inequality will not be a trouble. Okay. Now we have expressing the inequality, page number 3.8. Okay. The example which is given, we are trying to do it and we are analyzing each and every point. A company has 2 products, A and B, for which processing is done in 2 machines. So similar to the last one, company has 2 products, A and B, and there are 2 machines, M1, M2. Now the first machine can be used maximum time for M1, maximum time. It can be used for 60 hours. Okay, please open the problem. I'm also writing the data here on the whiteboard so that it's easy for you to follow. The second machine can be used at most for 40 hours. Okay, so maximum time for the second machine M2 is 40 hours. So you get 2 ceilings. I can use the first machine for maximum 60 hours. You know, every machine has a bearing capacity, right? You put on an AC. Yes, it runs for hours, but not for days. You open your computer, you open your laptop, you work on the laptop day in, day night, but yes, after a certain time, it has to stop. Auto stop function, right? A mobile also has to stop. It has to be switched off for some time. So here again, the machine has a maximum running time of 60 hours, which is like a ceiling, a cap. Also, maximum time for machine 2 is 40 hours, beyond which it cannot work. So these are called constraints. Okay. Constraints means what? Anyone? Limitations. So it means limitations. Okay. Can there be negative production? No. Can I say that yes, I have produced minus 10 tons? No, I cannot. So, not possible. Limitation. Okay. Say I have a capacity, my production unit has a capacity of 100 tons. Can I claim that I have produced 120 tons? It's not possible. My machines have a maximum capacity of 100 tons. So, it is a ceiling. I cannot go beyond that. Even if I am the best student, I cannot get more than 100 in any subject. So for me, 100 is the limit. Yeah, 40 might be the floor. Passing percentage is 40. But the highest is 100. So the range is 40 to 100. That means my marks will be greater than equal to 40, but less than equal to 100. I hope you understand. If I want to pass an exam like CA Foundation individual papers, I must make sure that my marks is between 100 and 40, right? I mean, 100 is out of the question. It's only for super duper. Some of you are like that, right? Genius. But for a very average person, okay, 40 to 60 maybe, right? So it should be more than equal to 40, but at least, more than equal to 40 is basic necessity. If I score below 40, I am gone. 40 is the threshold. 40 is the floor. Lower end, and 60 or 100 is the higher side, the upper end. Okay. So you can see here, two machines, they are given, you have a constraint given, you have a constraint. The constraint is maximum running time is 60 hours for machine 1, maximum running time for machine 2 is 40 hours. Now, the product A, it requires 2 hours on M1 machine and 1 hour on machine 2. 1 unit of product A. 2 hours on machine 1 and 1 hour on machine 2. And product B requires 1 hour on machine 1 and 2 hours on machine 2. Okay. So you see, this is also like a matrix. Ultimately, it's an array of numbers. 2, 1, 1, 2. Okay. Fine. So it's an inequality problem. Fine. So the question is, express the given situation in the form of linear inequalities. That means we have to use linear inequalities to show, to demonstrate the problem, to represent the problem, which is given, the situation which is given. Now the question is, you see, they are using for 1 unit takes 2 hours, right? So if I have, say for example, I am producing X items, product A, I'm say product A, I have X units. Product B, I am producing Y units. Okay, so X units product A and Y units product B. Okay, now the question is, how much time will I take? Like for 1 unit, I take 2 hours, product A, on machine 1 and 1 hour on machine 2. Okay. So, if you see, maximum, if I want to look at machine 1 only, so just like this, machine 1 only. So, machine 1, what is the total time? If I produce X units of product A and Y units of product B, what is the total time which I take? Now 2 hours I take for 1 unit of A. So I am producing X units. Okay. So how much time will I take? 2 into X. Is it clear? 1 unit of product A requires 2 hours. So X unit of product A will require how much? 2X. So you have 2X. Okay. 2X is done. Right? Now the question is, this is for product A. For product B, you require 1 hour. 1 hour per unit. But I am producing X units. So I will take how much? Sorry, I'm producing Y units. Product B is Y units. Y. So it takes 1 hour on machine 1 for product B per unit. So if I produce Y units of product B, it will take how much time? Y hours. So the total time during which machine 1 is used will be 2X plus Y. Please see if it is correct. M1, M2. 2 products A and B. 2 hours on machine 1, 1 hour on machine 2. Okay? 1 hour, 2 hours for on machine 1 for product A, 1 hour on machine 2 for product A. For product B, 1 hour on machine 1, 2 hours on machine 2. So we are assuming X units of A is produced, Y units of B is produced. To produce X units, how much time do I take? I will require X units of A. Okay. I will require how much? So I will require basically on machine 1 the total load is what? Machine 1 is handling both product A and product B. For product A, I am producing X units. So the total time is 2X. And for product B, right, I am producing Y units. 1 hour into Y is Y. So 2X plus Y is the total time during which machine 1 is running. But you are given a ceiling. What is the ceiling? Ceiling is here. Maximum time is 60 hours. So you can understand the relation will be 2X plus Y is the total hours during which machine 1 is running. Can it exceed 60 hours? No, because the ceiling is given 60. It is a constraint. I hope you understand. So 2X plus Y less than equal to 60. This is the equation. Alright, put it in equation. I hope you understand. Not that difficult like maybe comparatively like matrix and determinants, but this is light. That's why I kept it for the end. 2X plus Y is less than equal to 60. Let us do it for machine 2 now. I request you to work it out independently. For machine 2, how much do I produce? Y units. For product B. Y units. Y units. Now, for product B, it requires 1 hour on machine 1. 1 unit on machine 1 takes 1 hour. I am producing Y units. Okay. Fine. So I am producing Y units of product B and product A. Now let us look at machine 2. Okay. So we have already done the first one on load on machine 1. So I am writing M1 for machine 1. The total time is 2X plus Y. 2X plus Y. 2 hours for product A, 1 hour for product B. And the maximum time cannot exceed 60 because the limit is given. 60 hours limit is given. So the equation was 2X plus Y less than equal to 60. Now we are trying for machine 2. So we are now trying for machine 2. Machine 2 also has to work in order to manufacture 2 products. Again we have A and B. But for machine 2, product A requires 1 hour per unit. And I am producing X units. So, 1 product, 1 unit takes 1 hour. X units will take X into 1, that is X hours. Done. Machine 2 handles both A and B. So, A is done, X. Now for B, it takes 2 hours for 1 unit of product B. And I am producing Y units. So the time it will take is 2 into Y. So X plus 2Y. Okay. Now the question is, like first equation we had, first relationship we had with respect to machine M1, this one we are doing with respect to machine M2. So X plus 2Y is the total time during which machine 2 is working. Machine 2 is kept on. Machine 2 is operating. Machine 2 is occupied for producing the products A and B, X units of product A, Y units of product B. But, the problem clearly says that for machine 2, the maximum time is 40 hours. That means machine 2 has a budget. Later on in IPCC, we will study about budgets, budgetary control. So machine 2 has a ceiling, 40 hours. Beyond 40 hours, it will not work. You may have to go for a maintenance. You may have to go for oiling. You may have to go for changing the filter. You may have to go for lubrication, whatever it is. It has to be kept off so that it has rest. It cools down. So ceiling is 40. As simple as that. For machine 1, ceiling is 60. For machine 2, ceiling is 40. Okay. So the equation becomes, that means the total running hours of machine 2, can it exceed 40 hours? No, because 40 is the ceiling. Just as for machine 1, it cannot exceed 60. For machine 2, so the relation is 2x plus 2y has to be less than equal to 40. Okay. So this basically is what is inequalities. This is a type of problem which comes every year every term in the CA foundation exams, you have to attempt these questions, right? So I think this is now clear. We have broken down and we are trying to see the constraint, right? We are looking at the constraint. Accordingly, we are fixing the relation. Less than equal to, and here also less than equal to. We are linking it with the given constraints, right? Now we will take next one, page 3.9. Okay. So it's very logical and interesting if you see. And inequality is something we find every day in life. A person earning in Bangalore in a normal job and a person in Dubai or Oman in a similar capacity. Yes, the earning cannot be equalized. The person abroad in terms of Indian money will be earning more. So inequality, right? So these things have happened. Every finger is not the same. All 5 fingers are of different size. So they are not equal. So inequality is something which we see in life, right? And SUV's price is much more than a small hatchback. So prices will not be equal, dissimilar. Okay, fine. So let's go to page number 3.9 and let us take this example. The question, please open. A fertilizer company produces 2 types of fertilizer. This is called grade 1 and grade 2. 2 fertilizer, grade 1 and grade 2. I'll write grade 2 like this. Roman 2. Grade 2. Now, there are 2 plants, chemical plants. Let's call it C1 and C2. These are the plants. Okay. So you see, this chapter is interesting. More of understanding, less of memorizing. It's more based on concept. The quicker you are in identifying the constraints, the quicker you are in able to translate the given condition in the problem into inequations, you are successful. So, how to develop the habit? By doing more problems, by thinking deeply, okay, and by searching. You know, people are asking shortcuts. There's no shortcut. You have to just be sharp. Think of the logo of ICAI, CA, okay. You see a bird in the logo and you know the motto of the Institute of Chartered Accountants is what? Ya Esha Supteshu Jagriti. That means to be awake and sharp. Awake means what? To be alert, to see things around you. So quickly you have to see the given condition in the problem. And the logo of the institute you see is a Garud, is eagle. Eagle is sharp. Eagle is alert. Eagle flies high. Eagle flies above the clouds. Eagle has vision. Same thing in mathematics. Same thing in accounts. Same thing in law. Quickly look at the problem. Use your vision. Third eye. Right? And quickly understand the person who is quickest will become the best in marks. Okay. So here again, let's see the problem. Complicated to look at, but we have to quickly understand and absorb and convert the given condition into inequality. So there are 2 groups, 2 grades of materials, 2 chemical plants. Plant A and plant B. So let's call it CA and CB, plant A and plant B. Now plant A has a maximum budget in terms of hours and it has 120 hours. Okay. In a week, of course. So hours per week. Beyond 120 hours, you cannot run this plant. And plant B has a maximum of 180 hours per week. Okay. Now, manufacturing 1 bag of grade 1 fertilizer requires 6 hours in plant A and 4 hours in plant B. Sorry, I'll put it here. 4 hours. 6 hours and 4 hours. Okay. So it requires 6 hours in plant A and 4 hours in plant B. Okay. And grade 2 fertilizer. So this was grade 1. For grade 2, it requires 3 hours in plant A and 10 hours in plant B. Okay, 3 hours in plant A and 10 hours in plant B. Right? Okay, you are okay? I think you are following. I have deliberately done similar problem so that you can understand and you can now pick up. Okay, short time. Time is a constraint. 2 hours only. We have stretched it by half an hour more. 2.5 hours. Almost we are running for 2 hours 20 minutes. Okay, so I am like a machine going on, but I have a limit, cap, like you have a limit. The internet, everything has a limit. Okay, it's a constraint. So, you can see for grade 1, right, it is 6 hours in machine A and 4 hours in plant B, plant A and B. And for grade 2, 3 hours in plant A and 10 hours in plant B. You have to express this into inequalities. Express. So, understand, identify, express. Of course, MCQ will be given, 4 alternatives are given, you have to pick up the right alternative. So let's work on it. Now, let us denote number of bags. Since they're talking about bags, it's a cement unit, so bags of cement. So let's have grade 1, let's call X1 bags, and for grade 2, so grade 1 is X1, grade 2 is, let's give it X2 bags. Okay, so they're manufacturing grade 1 and grade 2 cement and, fertilizer and X1 bags of grade 1 and X2 bags of grade 2 fertilizer or cement, whatever you take it. So is produced. Now the question is, there is a cap on the number of hours. You can see grade, or if you see machine A, plant A has a maximum operating capacity of 120 hours. So you can call it, we normally use the term operating maxima. Maxima means the maximum level and minima means the minimum level. So maxima is 120 hours and for plant B it is 180 hours and for each bag of fertilizer it takes 6 hours on plant A for the grade 1 and 4 hours on plant B for grade 1. For grade 2, 3 hours on plant A and 10 hours on plant B. Dear friends, have you observed that these are all related to industry, production? So I hope you can understand this inequality chapter actually teaches us optimization, minimization, and ultimately this will have an application in cost management. How to minimize my cost, how to maximize my revenue, how to maximize my profit. So this is what we will be learning from this chapter, and this is the objective why this chapter is included in your mathematics and why it is part of the curriculum. Okay, so now if you see, let us see again plant wise. Okay, because in the problem plant wise they have given plant A maximum 120 hours, plant B maximum 180 hours. So let us take first plant A. Okay, so we are taking plant A. In case of plant A, you can see that ultimately 6 hours grade 1 to produce 1 bag. Now I am having X1 bags of grade 1. So the time I will take, so this is, I am calculating the time. Okay, and this is the limit. I am manufacturing X1 bags of fertilizer. 6 hours it takes on first in plant 1 to manufacture a 1 bag. So for X1 bags, the total time will be 6x1. Simple. For 1 bag, 6 hours. For X1 bag, 6x1. Okay. Now the question is, plant A handles both grade 1 and grade 2 fertilizer. So 6x1 pertains to grade 1. Grade 1. But I also have grade 2. So grade 2, I require 3 hours for each bag of grade 2 fertilizer, and I am producing how much? X2 bags of grade 2. So the total time I will take is, for 1 bag it is 3 hours, for X2 bags it is 3x2. So the total time on plant A is 6x1 plus 3x2. And you can understand clearly that this total time has a ceiling, has a cap, and the ceiling is 120 because I cannot run plant A beyond 120 hours. Okay, so the relation is 6x1 plus 3x2 up to 120 hours. Please remember, up to 120 hours, less than or equal to. So the relation is less than equal to 120. Right? This is for plant A. What will happen for plant B? Just apply your mind. Just work with me. Plant B. We have for plant B, we are having 4 hours. Grade 1 requires 4 hours on plant B. Grade 2 requires 10 hours on plant B. So dear friends, please see, ultimately this is also a type of matrix, array of numbers. Right? It's an arrangement of numbers. 6, 3, 4, 10. Again we have 120, 180. We are dealing with numbers. And the numbers are related. They are interlinked. They pertain to each other. They are not isolated. They are in relation to the same situation. Right? So, for plant B, what will be the situation? I am producing X1 units of grade 1 fertilizer. Okay? So, I am writing here X1 bags and 4 hours required for 1 bag. So, for X1 bags, the total time will be 4x1. So, I write here 4x1. Okay, this is for plant 1, this is for plant 2. 4x1 hours, but 4x1 pertains to grade 1. Now for grade 2, I require what? I require 10 hours to produce 1 bag of cement. But I am planning to produce x2 bags of cement. So the total time I'll take is 1 bag 10 hours, x2 bags 10 x2 hours. So the total load, the burden on plant B is 4x1 hours for grade 1 fertilizer plus 10x2 hours for grade 2 fertilizer, grade 2 and grade 1. This is the total time. We have calculated it as per the given situation, as per the given conditions. Now, last part is again optimizing, setting a limit. Yes, total time is required. We have found the total time, but there's a limit. In equation we equate. Here we have to set a limit. Either left hand side is more or less than a given number. And the given number is here, 180. Because it is given in the problem that plant B has a maximum operating time of 180 hours in a week. So 180 is the ceiling. You can call 180 as the cap. You can call 180 as operating maximum. So very similar to 1 for the machine 1, the plant 1, 6x1 plus 3x2 should be less than or equal to 120. This will be 4x1 plus 10x2 should be less than or equal to 180. First one was 120, this is 180. Given the conditions. So the answer you can see is, the question was, please set inequalities as per the given situation. We have done it. The answer is this. 6x1 plus 3x2 should be less than or equal to 120 and 4x1 plus 10x2 should be greater than or equal to 180. And of course, please don't forget to also mention that x1 is what? The number of bags produced. It has to be positive. So it is greater than or equal to 0. X2 is the number of bags produced for grade 2. Can it be negative? Can production be negative? No. So x2 is also greater than or equal to 0. Okay. So this is how we do the optimization. And the last one we take is graphical example with which we will close. It is 4:30, but we are still, capacity is there to continue. So we continue for another 10 minutes, 5-10 minutes, and we complete the last part so that inequality part will be done. And later on we will just do a few examples to understand. These are the principal types of problems which come from inequality. Otherwise, the chapter is very small. Okay, now we have to draw. I will request you to go to page 310, 3.10. Okay. Okay, so 3.10, we will do the example. The question is, draw the graph of the solution. So we have to draw the graph of the solution of the following inequality. They have given x plus 2y equal to 4. So this is an equation, linear equation, and x minus y is less than equal to 3. Okay, so this is the graphical form. So let's try the graphical form. Okay, so now how to draw the graph? Okay, first equation is x plus 2y equal to 4. Okay, let us take this one first. X plus 2y equal to 4, and you have got another, not an equation but an inequality, x minus y is less than equal to 3. Okay, so for first equation, x plus 2y equal to 4, right? So let us draw a small box. Please do with me and please practice with me so it will be easy for you. How to draw lines. You know, you are given the equation. We'll learn something very interesting. Why is it called linear equation? Every time you are, you have heard this so many times, linear, simultaneous linear equation. Why linear? Because it can be drawn in the shape of a straight line. A straight line. Like demand. This side quantity, this side price, demand curve. It can be curvilinear also, but sometimes we draw it like this. Why? Because as quantity increases, price falls. More the quantity, less is the price. So it's a linear equation. Okay. Supply straight. So this side. So it is again linear because as price increases, what happens? Quantity also increases. But in case of demand, as price increases, quantity falls. Okay. So you see why this is called linear. Many of my friends, in the last 2-3 sessions sent me questions saying that, sir, why it is called linear equation? Okay. So now you will understand this because now we are going to draw the graph of x plus 2y equal to 4. Interesting. Very simple shortcut, quick shortcut. Please note. X plus 2y equal to 4. So first, step number 1, write x and y in the box. Okay. You know that to draw a straight line, you need 2 points. You need point A and point B. I give you 2 points, any 2 points you can draw a line. So you need 2 ends. We will find these 2 ends. How? You write x and y here. Okay. Now, what happens when x is equal to 0? When x is equal to 0 in this equation, what is the value of y? Please, try it out. When x is equal to 0, so what will happen? 0 plus 2y equal to 4. So y will be equal to how much? 2. So I write x is 0, y is 2. Fine? Now, we have assumed x at 0, so we get y equal to 2. So now we find if y is equal to 0. If y is equal to 0, this was x equal to 0. If y is equal to 0, what will happen? 2y will be 0, so x will be equal to 4. X plus 2y is 4. If y is equal to 0, then x has to be equal to 4. So we write 4. Okay, I hope this is, you're following, clear. So now, we do the same thing for this equation. X minus y is given greater than equal to 3. So let us assume x minus y is equal to 3 because they have said it is greater than equal to, less than equal to 3, less than equal to 3. So it is either less than 3 or equal to 3. So let us assume it is equal to 3. and we draw a similar box. X, Y, we will take two values of X. We have taken two values of X. So X has the value 0 and 4. Okay. And Y has the value 2 and 0. Let us do the same thing here. Why we are taking two values? Because we have to draw a straight line, and to draw a straight line we need the two ends. Any 2 points. You can always draw a straight line through 2 points. I need 2 points. And how to get the 2 points? By setting X is equal to 0 and by setting Y. So X equal to 0, you get Y equal to 4. And once you set Y equal to 0, you get X is equal to, when you set X equal to 0, you get Y equal to 2. When you set Y equal to 0, you get X is equal to 4. So the same thing we do here. So when X is equal to 0, in this equation, what happens? X minus Y is 3. X is equal to 0. So Y is how much? Y becomes minus 3. So when X is 0, if Y goes to the other side, minus 3 comes here, so Y is minus 3. And when Y is equal to 0, if Y is equal to 0, what will happen? X will be equal to, when Y is 0, X will be equal to 3. Please see if it is correct, if you understand it. So this is the last part of inequality, because ultimately if you see the chapter, more examples are given, but the fundamental principle we have covered, fundamental examples from the study material we have already done. That's why I told in the beginning of this session that this chapter is not a big chapter, just basic concept, two basic concepts. One we have already done, optimization problem, creating inequality from given conditions, and the second one is drawing graphically and showing the inequality and showing the shaded area. Okay. So now we know this. This is, this we know, we call it coordinates. We always say, please coordinate with me. I was requesting you right from day one, and you are doing it. I said that please coordinate with me. Please coordinate with the institute. Please coordinate with your teacher, your faculty. Okay. So, coordination means to be aligned. So now we draw the line. Okay. So you know the x-axis is the horizontal axis and y-axis is the vertical axis. This is 0. Okay. Now x plus 2y, the first equation, I'll use red here. X plus 2y equal to 4. We have got these values. Please follow carefully. Very carefully. We are now plotting this equation. So equation is x equal to 0, y equal to 2. So x equal to 0, y equal to 2. So x means movement in this side, 0. First is 0. So no movement. I will stand here. Then I have to go 2. Y is 2. X is 0, y is 2. So x, no movement, it is 0. Neither this side, nor this side. I am straight. Neither am I moving this side, nor this side. Straight, 0. Okay? Y2. So y, I have to go along y-axis 2 steps. 1 step, 2 step. So this is 1 point. X 0 and y2 we have got. Second one is x is 4, y is 0. X is 4 means plus 4. So we have to move along the positive axis. 1, 2, 3, 4. We take baby steps. 1, 2, 3, 4. 4 steps. But y is 0. So I don't have to move up. I don't have to go down. So the point is here. We have got 2 points. So we draw a straight line. Let me see if I can draw it. Draw it. Yes. Straight line. This line represents x plus 2y equal to 4. I hope you understood. This is why it is called linear equation, because these equations can be shown in a straight line. Line and linear, same. It sounds same. The word linear comes from the word line, so it can be shown. Similarly, I will use blue color to draw the other equation. x minus y equal to 3. Right? So 0 and minus 3, and we have 3 and 0. So first one is 0 and minus 3. Let us find out these 2 points. 0 minus 3. Okay. So 0 minus 3 means x-axis 0. No movement. No movement horizontally. I am 0 at 0. Okay, I am 0. If I move this side, I am facing like this. If I move this side, it is minus. If I move towards the right hand side, it is plus. But it is 0. So I am standing still. I am standing still. No movement this side. So 0. Y minus 3. Minus direction is downwards. So I go 3 steps. 1, 2, 3. So I know this point is 0 minus 3. This is like GPS. Every place on the earth can be connected. You have read about latitude, longitude. GPS means what? Every point on the earth has a coordinate. Okay, this degree east, this degree north. Same thing we are doing here. You know this is the north direction, this is the south direction, west and east. It's like that. So we have got this point. First point. Next one is x is 3 and y is 0. So the next line, if you see, is x is 3 and y is 0. So x is 3. 3 means positive. So 1 step, 2 step, 3 step. But y is 0. So neither we will go up nor we will go down. Y is static. 0. So these are the 2 points. So I will draw a straight line. Okay. So the blue one is the equation x minus y equal to 3, and the black line is the equation x plus 2y equal to 4. Right? Now the last part, that is, if the question is x minus y should be less than equal to minus 3. It has to be less than equal to minus 3. The equation is x minus y equal to 3 is this, blue. So less than means what? Left hand side. It is less. Left hand side. So the entire region, now I am marking it. The entire region, whatever I am marking with the red color, this is the solution set. This is the solution set. Okay. So this is what the question said. We drew the 2 lines. We assumed 0, x equal to 0. We set x equal to 0. We got y. We set y equal to 0. We got x. Right? And we got 2 points. So we are able to draw the lines. Both the lines are intersecting somewhere. But since the question is x minus y is less than equal to 3, we know less than means towards the left. Right hand side is positive. Left hand side is less. Right hand side is more. See, you are driving a car. Okay, speedometer is going up, 60, 70, 90. As you move towards the right, it is more. As you move towards the left, it is less. When you are braking the car, okay, 40, 30, 20 and stop, 0. So left hand side means speed reduces. So left hand side means less than equal to. So we have done it left hand side. Left side of this line. So this, using a ruler, so it's extended. This shaded region is the solution of the equation, that is x plus 2y equal to 4 and x minus y is less than equal to 3. So friends, we are completing today with this. We have done a lot of work today. We started with so many responses to your queries on matrix. We understood about the diagonal matrix, the scalar matrix, identity matrix. I discussed about AB and BA, matrix AB and inversion, the commutative law of matrix. Then we saw determinants once again. We did determinants of 2 by 2. I also did determinants of 3 by 3 matrix. And then we learned the Kramer's rule, where we saw that in case of x and y and z, right, x is basically determinant x by determinant, y is determinant y by determinant, and z is determinant z by determinant. And we solved questions. From there, we went into inequalities. In inequalities, we learned about greater than equal to sign, less than equal to sign, and then we first saw what is optimization technique. What is optimization technique? That means how to increase. What is the equation for increasing the profit? We took examples from the study material. We saw how to increase or decrease, right? How to optimize the working hours planned. Maximum working hours were given. Production in terms of a number of units we did. Multiple problems. And then we completed with a very interesting problem on the graphical way. And now I hope you have better idea why linear equation, because it can be shown through a straight line, and that is how we plot an equation into a straight line. And finally, we saw if x minus y is less than equal to 3, why it is on the left hand side, the solution set. I hope you can now follow. So dear friends, it's almost 4:50. I think we have done framing inequalities, we have completed graphical method, and we have done optimization. There are some more problems from the study material, from the exercise, which we will take up on a subsequent day if I get an opportunity once again to interact with you. So till then, thanks a lot for watching. Do send your comments. I will try to filter them and get back to you with my responses as I have done today. Thanks to all those 179, 180 dear friends, dynamic friends who were connected and who sent their queries. And I hope I was able to, shortlist most of them. And I took the relevant cases and tried to give my responses, supporting you with exam strategies and also covering the topic which is given to us. So we could complete the matrix chapter, determinants, and we did the Kramer's rule, and we have also done inequalities, which is divided into two areas: optimization equation, setting inequalities on optimization, and the graphical method, which we have done. So with that, I come to the end of this particular session as part of the VCC, the virtual coaching session. Please go through the video once again as at your leisure from YouTube. Go through the presentation. I have already shared it with the institute, and start practicing, start studying the chapter once again. I'm sure you will get light, you will know better, you will have confidence. Till the next time we meet, thanks and stay safe. Thank you.